Okay. In the MFCA, today we're going to talk about one of the materials that we use in engineering, actually civil engineering, concrete as construction material. As a prefix, if we want to talk about concrete, and if I want to tell you an abstract about concrete, I should say concrete is one of the most used building materials on earth, okay? You know why? Because the use of concrete all around the world is diverse. Because the availability of components and the ingredients that we use in building and making concrete, it is very popular among engineers. This is about concrete. We can use it in building dams, skyscrapers. We can use it in asphalt. As you know, asphalt is a kind of concrete, but the paste of asphalt is bitumen. And we can use it in the foundation of the structures also. This is the components of concrete. That concrete has two main components, paste and aggregates. Paste also has two main subdivisions, cement and water. In this conference, we are going to talk about every single of them in detail. But I want to tell you a key feature of concrete. Concrete has two key features. First, it is malleable and flexible. Malleable means you can put it in any shapes that you want to. And flexible when newly mixed, when you mix the ingredients. And it is strong and stable when hardens and gets assimilates to water. We will talk about it later. Okay, first of all, we're going to talk about cement. Without knowing cement, we cannot get familiar with concrete, okay? So, let's talk about cement. Cement acts as the heart of the concrete. It's a kind of glue that sticks and links all of the ingredients, all of the, let's say, the ingredients, the components together. In order to create the cement, we need limestone, as you can see here, clay, and other elements like iron. We crush all of these ingredients, all of these components to a powder, and we transfer them to a machine. It's spinning, massive machine that we call it kiln. This is a technical word. This is kiln, as you can see. It increases the temperature of this mixture.
K-I-L-N.
L-N, exactly. And it increases the temperature of the mixture to 2,700 Fahrenheit. It is for sure a high temperature. And it is partially melted. Once cooled, that mixture, once cooled, they will become these kind of shapes. We call them clinkers. And when we crush these clinkers by a machine, that we are not going to talk about it, we will have cement, a super fine powder, but that we know as cement. Okay. Let's talk about aggregates. As you know, in the previous semester, Dr. Sultani has talked about these subjects in a perfect way, in a complete way. So we are not going to talk about them again, but I want to review the things that you have learned. As you know, aggregates are divided to main categories: fine aggregates and coarse aggregates. The finest aggregate is clay, and the coarse one, the most coarse one, is gravel. We have some other aggregates in between them, like sand and silt. So this is the let's say a mind map of aggregates. But if you want to compare in comparison between aggregates and cement, which one is more effective and more, let's say, efficient in workability of concrete, we should say, because cement is a brittle material, so because of that, aggregates are more efficient in workability and durability of concrete. Okay. Water. There is a common mistake that random people believe that many materials, specifically we are talking about concrete, right? Concrete hardens by drying. It is not correct. It's a false statement. The truth is, concrete hardens and gains and obtains strength by assimilating the water. Assimilating means obtaining, getting the water. Okay, this is the truth about water. Okay, if you want to talk about, let me tell you something. If you want to talk about water, let's say the job of the duty or the performance of water in this mixture is that we should talk about hydration. Because of hydration, we use water in this mixture. So, what is hydration? This is hydration, as you can see. Let me show you. This is in the first time, just watch. Then I will explain. Okay. These dots. These are aggregates. This is water. Those round shapes are crushed stone, rocks, and this is cement. As you can see, this is cement. And these ball shapes are nodes. What are nodes? When cement assimilates, gains water, some of the nodes appear. And these nodes links and connects to other nodes, and cement, this material, this miracle material, covers and coats all of the mixture, as you can see. This is the meaning and the concept of hydration. Okay.
Actually,
yes, sir.
The hydration. Sorry. When we are talking about the hydration, it means the absorbing water into the molecular structure. It means a unit of H2O must be contribute in the structure of another molecule to produce a new substance, a new matter. The hydration usually produces heat. All hydration reactions produce heat. Hydration reactions is very common in concrete environment, in cement environment. And by hydration, you can generate, you can produce a new material with a particular characteristic, chemical and physical features, quite different with that was in the before. Really quite different. So, hydration is the most important reaction that is occurred in the concrete environment. Okay, keep
Thank
going.
you for the additional information. Okay. We talked about the components, but this is not the only factor in creating and building concrete, okay? The most important thing is proportioning. Proportioning means طرح اختلاط. Proportioning is the most important part. In proportioning, we have a ratio. This is a ratio. Weight of water divided by weight of cement. The denominator of this fraction is weight of cement. If we try to lower this ratio, we will have more, let's say, durable or workable concrete. Okay. We have various proportions. It's like making a cake. You know, we have lots of recipes for making a cake, right? Because of that, this is just a sample, just an example of one proportioning you can see here. We have air, Portland cement, coarse aggregates, fine aggregates, water. But what is amazing about this, let's say, shape is that coarse aggregates are creating the concrete, the bulk of the concrete. They composes the bulk of the concrete. This is the main thing that we can say about this proportion. If you want to know more, you can research about it. Okay, every single statement that I said and I told you in this conference has a background, has a reference. You can check them out. Do not believe me? Check them out. Okay, if you want to have the PowerPoint of this lecture, this presentation, you can download it from my personal webpage, and this article, the transcript, what I said, the written form of what I said, you can download it from this URL. Okay. Any questions? Thank you for giving me your time. Thank you.
خب ببینید من خیلی ممنونم، تشکر میکنم از